Hello, this is our Friday lesson, so let's do our do now. Question 1. Roller coasters are popular attractions at amusement parks. A cart on a roller coaster approaches the highest point on the coaster. As the cart reaches the top, it slows down. Which statement best describes the energy of the roller coaster as it slows down while traveling to the top of the coaster? A. The cart gains both kinetic and potential energy. B. The cart gains kinetic energy and loses potential energy. C. The cart loses kinetic energy and gains potential energy. The cart loses both kinetic and potential energy. So make your choice. I'm going to read question 2. Where on the roller coaster described above, so the one in question 1, does the cart have the greatest potential energy? Let's think about that. Well, let's go back to the first problem. All right. Yesterday we reviewed and talked about how the carts gain and lose potential energy in that great video on the roller coasters. And can we gain both kinetic and potential at the same time? Absolutely not. You're right. Thanks for that answer, friends. The cart gains kinetic energy. Well, kinetic energy is energy of motion, and potential is energy of waiting or standing still or potential. So are we gaining or losing? That's right, we're gaining potential. So that does away with question B. So we can't gain kinetic energy, so that would mean D is incorrect. So that leaves us with the correct choice of C. Where on the roller coaster does the cart have the greatest potential energy? That's absolutely right. Thank you, everybody. It is at the very top, at the highest point. So right here, is today's learning targets. We're going to watch an IB community video project after we go over some of the slides on calculating speed, and you'll learn to calculate speed given measurements of distance and time. That you can differentiate, which means tell me the difference between speed, distance, and time based on units. I can read a scenario and set up a question to solve for speed. That means reading a word problem, and I can solve for speed. So we're going to skip past the IB video. That is slide number 3. You can click on this, and it'll be contained within your slides here, and you can watch this. And this is a great, this is the half of the launch of the IB project. The other half will be presented to you in social studies. So I'm going to skip to slide 4. And this is actually slide 9, I believe, in your notebook. So here we're going to start with speed is equal to distance over time. And as you look, distance is measured in things like miles, meters, kilometers. And that we measure speed in miles per hour, kilometers per hour, meters per second. If you notice, there's the word per, like each. And time could be hours or seconds. So that's kind of cool. So you're going to want to drag and drop so that your slides, there's items over here on the left, match mine here. So how would you calculate speed? Absolutely, you divide the distance by the time. How would you calculate time? You would divide the distance by the speed. And yes, you would calculate distance by multiplying. See here on the chart? If you click on this little calculator in your notebook, it does have a calculator. You'll be given a 4-function calculator for the test. So let's look at this. What do I have and what am I missing? Oh, well, we highlighted the important parts, 3 hours at speed. So I have speed and I have time, so speed and time. So I'm multiplying here to get distance. So 3 times 40 would be, that's right, 120. All right, let's look at example 2. A car travels a distance of 540 kilometers in 6 hours. So I have my distance over my time, and if I divide that out, I get 75 miles per hour. On our next slide is speed can be calculated. How can we calculate speed? So just copy this first part, paste it here, look back on the slide on slide 9. Speed is distance, dividing distance by the time. So you can do that right here. So you're going to show your work or travel and use your calculator to solve. So in this one, I have meters and seconds. So I have distance and time. I'm looking for speed. How far? Oh, there's a clue. Far, that's a distance word. can your brother travel, if he can travel at 2.5 meters per second, that'd go here, times 5 seconds. Take care of that math. Or how much time will it take for a bug to travel 5 meters across the floor if it is traveling at 1 meter per second? So you take your distance, 5 meters, and divide it by your time, your speed, 1 meter per second, to come up with our time. That's awesome. And then just try this if you're at home. If a car travels at 240 miles in 6 hours, what's its average speed? So that would be 240. It'd be 240. Let's do this here. Divided by, 6. And 6 goes into 24 4 times. Do some short division here. That gives me 24. And then 6 goes into 0 times. So there we go. That would be 40 miles per hour would be that bug's average speed. All right. I want to thank you all for joining me today. Just giving you a quick heads up. Monday, we're going to work on speed calculations. So I'm not going to post that video till the end of the school day because we may make some adjustments as we go along during the week. Please watch the videos every day. Do the best you can and always try hard. Please remember, grades were entered Friday. Progress reports will be posted tomorrow, Monday. If you need to get any late work in, you need to notify your teacher in an email with your name, exactly what assignment you redid, and which redo or resubmission did you give us. So please make sure that's in a detailed email to your teacher. All right? Because we want to make sure we give you all the credit we can because, believe it or not, in 2 weeks, we are going to be out. Actually, you're going to be out in 2 weeks and 4 days. Be out for the semester. We just post grades on Friday. So have a great day, and I'll see you all Monday.